So all the networking services or features Amazon provides, this is one of the important feature that Amazon has. Route 53 has a very interesting name. Just to give a little bit background, 53 is the DNS port, as you might already know. And when you say Route 53, it just looks like a highway traffic, and it is one of the biggest roads in American highways. So it's a symbolically reference to where the high traffic flows in, where the different directions you can take, and the 53 refers to the DNS port. That is how they named this service. Sometimes interviewers or people chat about this when you're having a discussion. Do you know why Route 53 is named for a DNS service in Amazon? Very nice offhanded discussion. But having said that, it plays a very crucial role in AWS group of services. There are 2 to 3 different type of configurations. At a very broad level, you have something called a private hosted zone. That is, within your VPC, you can have something like mynetwork.com domain name and route traffic within this mynetwork.com domain name. Or you can have anything crazy like mytestdemovpc.com and have servers registered within this domain, and all the traffic will stay within this domain. It won't go to the internet for DNS resolution. So something like that, if you don't have a domain name, you can play around with using a private hosted zone. And there is another option called a public hosted zone. That is when you need a domain name registered with a third party like GoDaddy or some other domain registrars, or you can use Amazon itself to buy your own domain name. For example, Vamsi.com or Kumar.com, anything that you can think that will help to launch your own business or start your own identity in the internet. So for whoever who doesn't know DNS, this is how it is. Like, you know a server name like example.com, and you don't know what is the IP address of that server, then they use the DNS resolver, asks the DNS service, I have this name, what is the IP address, can you give an authoritative answer? If this DNS solver and the server has that information, it gives an authoritative answer. If it doesn't have that, it will forward that query to another DNS server which is connected on the background to this service, and it will give an answer reply. Such a reply will be a non-authoritative answer because the first person I asked is not having that information, and I have to ask some other people to get that information. So it will say that I did not get that information from myself, so this here is a non-authoritative answer for you, and this is the IP address. And the browser understands the IP address, the internet routers understands this IP address and fetches the page from that IP address, and it goes. So DNS in simple terms is a nice fancy user-friendly name for the IP addresses for particular resources. That is what it is, a name resolution service that is used forever since internet is available. When it comes to Amazon, DNS is used, the Route 53 service is used in just more than a domain name service. For example, you have a lot of servers running under your DNS configured, then you can use your DNS itself as a health checking service. For example, 3 web servers are there under your example.com domain name, and you find that server 1 is having some issues. So Route 53 automatically stops sending traffic to server 1 because it has a built-in health checking service. Once you configure it, and if it is not getting a response from server 1, it will stop sending traffic there. So it also works as a health checking service and gives you notification of what is not working, what is working. So automatically your clients are not put into the trouble of finding that some server is not working. They don't have to refresh the query again, so they find a healthy working server. So in conventional way, let us say you have a GoDaddy domain name and you have 3 web servers configured, same configuration, and GoDaddy will not know whether your server 1 has gone down. It will still try to send traffic. So people who have the unfortunate event of going to server 1 will have to refresh their page to get to a healthy server. So that is how Route 53 slightly differs from other domain service that is available in the market. There are some dynamic DNS, dynadns.com. So many are there in the market. so some of them provide you health checking, but the comprehensive integration with other AWS services and also your load balancing capabilities within the DNS also differentiates Route 53. We will look at the load balancing capabilities all in the next few slides here. So some of the key features, DNS, Amazon gives a commitment of 100% SLA. If you remember, something like S3 has a durable availability of 4 nines, whereas the durability is 11 nines, but availability is only 4 nines in S3. But for Route 53, Amazon says, I am committing myself to 100% SLA. And also it gives you DNS and failover and advanced routing. Like for example, if the traffic is coming from India, I will try to send it to an India-based server. If the traffic is coming from a different region, I will send it to the nearest region. So that is the GeoDNS for you. Then you have the other routing policies, that is latency-based routing, and then weighted routing system is there. So we will look at each one of them slowly. And you have alias records also, that is, if anybody's done anything with the DNS, they know that for the same server, you sometimes need to create multiple records. So here Amazon also allows you to do that. It is slightly different from your CNAME. Your CNAME can again point to an alias record here. So for example, an S3 endpoint is there, or an ELB endpoint is there, or an EC2 endpoint is there. You can create an alias record for that as well. The flexibility with the CNAME and both alias records is unimaginable. You can bend them completely to route your traffic and shape your traffic. And finally, the private DNS is also there, which I talked about some time back. And DNS registration is also possible within the AWS console. And coming to the pricing part slightly, Route 53 is not a free service. I will repeat that, Route 53 is not a free tier service. Every domain name or every hosted zone you register, there is a bill of $0.5. Very small amount, but there is a bill for every hosted domain name. Under each domain, you can have 10,000 records. In other words, you can route traffic to 10,000 different resources. So, since there is a price associated with all the hosted zones, Amazon says, for testing, I'm going to give it for free. How is that is possible? I told you it is not free, and I'm saying it free is also possible. It is very, very time bound. For example, today 10 o'clock, I'm creating a hosted zone. And by within the next 12 hours, if I'm going to delete that hosted zone, Amazon is not going to charge you. That is what they are saying. So if you want to do testing, go ahead, create a hosted zone. But when you're trying to close your console and leave your console, make sure that you delete the hosted zone that you have created, delete all the records before that, and then you leave the console within 12 hours. So this way you can experiment with Route 53 without any additional cost. So having said that, there is no free tier. Just for experimental purpose, they are giving you a 12 hours of time to experiment. That is for testing some routing policies or anything. And be careful with the Route 53 service. Don't try to have an extravagant approach of starting dozens of domain names, dozens of record sets, and try to start crazy routing policies. There's a visual routing policy, and that routing policy is even more costly when you're trying to learn something. You don't have to do that, but just don't go ahead and start different services in Route 53. It is not like S3 where the costs are very, very minimal. It is quite a costly service because the availability is 100%. So they treat every single request with a lot of effort, and they try to put up resources on the background, and they charge for that in a very significant way. For example, if you are creating a complex routing policy, each routing policy costs you about $50, $50. So I will show you what you can do, what you cannot do in the console, in the demo part. But for that, now you remember that there are certain things you need to be careful when you're playing around with it. Here is a list of record sets that is supported. For people who know that some of those terms, very good. To be honest, I have not used all of them here. I have used A, I have used a CNAME, I have used a MX and NS. A is nothing but the Apex record. So if you have something like www.ibm.com, ibm.com will go into the Apex record. And for MX means it is nothing but a mail server. So for ibm.com, SMTP or IMAP or any other mailing protocol will be configured under MX. And this is a very common. Most people will be familiar with the name server record. This is the DNS service within your intranet or internet service. This pointer record and statement of authority up to this TXT stuff, I have not used it personally. If your enterprise asks you to configure these things, you can configure it. It's just a drop down. You just need to learn what are these records and you can configure them. CNAME is nothing but an alias for another domain name. So for example, if somebody reaches ibm.com and you want to redirect the traffic to, let us say, ibm3.com or something like internal.ibm.com, then you create a CNAME for ibm.com to point it to internal.ibm.com. Whereas this 4 A's, that is nothing but for before saying this, I will just go to A again. As I said, A is an Apex record. So ibm.com needs to be pointed to some IP address. A records always point to IP numbers. And A is for IP4, that is 4 octets you will have. Whereas these 4 A's are for IPv6, that is version 6. You will have 6 octets and you have to configure the 6 octets for that domain name. So that is the difference between A and that 4 A's records that you see. We will see that in detail when we look at the demo. There are health checks. There are a lot of text here. I'm not going to run through it. Health checks is as basically as it says. You find an outage, then Route 53 stops sending traffic or any backup policies or anything you want to. For example, ibm.com is down and instead you want to point the traffic to an S3 bucket which has a static website, then you can do that by using a health check. That is all health check is all about here. So in a if you want to have a pictorial representation of the same stuff happening, this is a simple failover configuration. Here you have a database server and a web server, and Route 53 does a health check and the health check says everything is happy and healthy. So you see the secondary pointer to a bucket which is inactive and you have gone phishing. So what happens when something goes wrong? The health check turns fail. Health check turns the instance into unhealthy. You can see the primary has become inactive and the secondary has become active. That is, that pathways or that record sets will become active and Route 53 will automatically send the traffic to your S3 bucket now. And you can trigger a notification on all those kind of things, so you can come back and fix your web server later. So this is a very simple failover configuration that is possible with Route 53. Moving forward, you can have complicated health checks, like a combination of multiple health checks. Is it refreshing for you guys? Okay. You can have CloudWatch alarms, you can have number of order measurements, you can have number of disk read writes happening in the database. You can have n number of complicated health checks and point it to Route 53 to pick an action based on that event. And also you can have a latency based measurement. Sometimes it is very important for some websites for having a latency based measurement. This is quite relevant in this use case. Think of this. This is quite common in the Western world. Flight insurance is very common in the Western world. They go to the airport and go to a kiosk, just nothing but an ATM kind of machine. They put in your credit card and say, this is my source and this is my destination and this is the time I'm traveling, this is the airlines I'm using. I want to buy flight insurance or travel insurance. And the website on the kiosk will show you the price, and then if the customer is happy, they just go ahead and buy it. It's just you're putting your credit card and details and then you just buy the insurance so fast. How is that important is the customer is going to buy that insurance only for that particular travel. If that website is not available during that time, you have lost that business forever. He is not going to travel every day. That customer is not going to come back again to say that that website did not work. I'll come back second day and then buy that insurance. That is not going to work. He has completed his travel. So the latency becomes very, very important in these kind of use cases. So the website has to be available when that person is in the kiosk, and the website has to respond within a short while. If in anybody in India, they might be familiar with the IRCTC kiosks in the railway stations. You go there, type on your train number or get PNR number, it spins for a while, and if you're lucky, you will get an answer. If you are not lucky, it will say something wrong on the back end, can't show the information. Think of that happening for an airline insurance company. If that kiosk is constantly saying that I cannot show the information, that means you are losing revenue. So in those kind of cases, latency-based health checks are very, very helpful to route your traffic to a healthy server. That is just an example use case. There are a number of use cases available. Just to help you, I said that it is nothing relevant to the class. If you didn't follow it, ignore it. And very, very simple routing policy is you check up at point to a particular domain name, and if it is not available, point it to an S3 website, S3 bucket. A complicated way of doing things is weighted round robin, latency based routing, and geolocation. We already talked about geolocation and latency, so I'll just talk about weighted round robin. This is nothing but a more mathematical way of approaching things here. You have a couple of routing policies and you give weightage to, a couple of health check policies or latency policies or any kind of a policy custom written, and you give weightage to each of them, and you take combination of that weight and ask Route 53 to decide whether to reroute the traffic or not. To give you an example, one metric will be checking my CPU of my instance, another metric will be checking my latency of my instance. So I can have a combination of these two metrics and have a weighted round robin saying this server is underperforming for these two metrics, let me point it to another server. Or you can say, for example, I am having a website where people are uploading things, and once you upload it, you need to view what you have uploaded. So for uploading, I will send my queries to one server, and for viewing, I will send my queries to another server. So this kind of complicated weighted round robins is possible with your DNS records, but you will not hit these kind of use cases when you're starting your career in AWS. This is more web scale, that is people for Instagram or Facebook or Dropbox. Those kind of people will require these kind of facilities to configure a round robin policy. But be aware that these three are quite often interview questions, or people ask you, do you know what are the routing policies available? So most common people do is geolocation based routing and latency based routing. So just be aware of the terms and tell them where possibly it could be used, and you will most probably clear that question without any difficulty. Okay, latency based routing and geolocation based routing. I'm skipping both of them because we have spent enough time discussing those two. Private DNS. Let me just go ahead quickly look private DNS and then a couple of slides, then we can delve right back into the demo, I guess. Yeah. So this is, as I said, you can have your own private DNS name inside your VPC and have your routing happening. And there is something called split horizon or split view DNS available. That is, let us say you're changing something in your domain name for your corporate company, and you want to test what is the impact of that kind of routing. So people do that in that case, add another domain name for the same public domain and try to shape the traffic internally and see how the responses is. It is called more popularly split horizon or split view, and it is mainly used for testing changes before going public, as is written here. So you can also use that for internal routing purposes. For example, once I had to set up a Hadoop cluster, I didn't have a domain name, but a Hadoop cluster quite often requires a domain name to be working. Namespace is very, very important in Hadoop clusters. So I had to set up a DNS server privately and make them all talk to each other using their host names. So I wasn't aware of split horizon at that point of time. If I was, I would have definitely used this service and private DNS to do that. So its uses are very limited for testing mainly and for doing a split horizon. Otherwise, I don't see much use for a private DNS at all in Route 53. And the next one is alias records. We also talked about it. You can have a alias record pointed to an ELB, and if the IP address of the load balancer changes, Route 53 will automatically reflect those changes without changing the hosted zone. One moment, guys. Sorry about the delay, guys. I just had to speak something here. Okay. What I was saying is alias records. It helps you to point to multiple places, the same record sets. So it helps in that way. You can configure it for CloudFront and also in bucket depending upon which is healthy, the traffic can be routed, or you can also have an alternate CloudFront distribution. So a combination of multiple things is possible with alias records. That is how it helps. The whole idea of Route 53 is, the way I see it is, your customers should see some kind of a resource from your company or your website. They should not see an page cannot be displayed or a 404 message. So you try to do a lot of things. You redirect the traffic when the instance is not healthy, or you point them to a static website, or you point to an old cached CloudFront location, or anything you do within your powers so that you don't lose the customer, you engage the customer and try to retain them in your website. Because the moment we see page cannot be displayed, 404, some error on the website, you tend to close that tab and go to some other browsing website or some other shopping site. So this is how this alias records, health checks, latency based routing, all those comes into picture. It is trying to retain the customer in your own website. That is the whole idea of it. So moving forward, I think the last slide talks about a DNS registration. As I said, if you want to buy a domain name, you can buy using Amazon Route 53 service. There is a tab for buying domain names, top level domain names, TLDs, and you can also transfer domain names from other services to Amazon. Amazon will also help you to auto renew them, protect your username and password, username, email address from other third parties, because people sometimes take over the email address of domain names and take over the domain itself. They can point it to their own servers, in other words. So let us say you have www.google.com is there and it is registered to a particular email address. If you somehow gain access to those email address, you can go to the domain name registrar and point google.com to your own home server. So indirectly you can steal that website and its traffic. This has happened to one popular domain for a torrenting service, and they finally gave up defending from the hackers. So when you transfer the domain name to AWS, they will protect your email address which is registered with, and they will also protect your private credentials. For example, you will provide your name and address and all those details when you're registering a domain name. So AWS will take certain precautions to protect you from those kind of issues getting leaked out to the general public. So let us go ahead and try to do a quick demo on the private and public hosted zones, and let us see from where we can go from there. I'm just going to Okay, this is the Route 53 console, and in case if you want to know how to go here, click on services, you type Route 53 here, it will pick up the appropriate resource link and you just click on that, and if there is no domain name configured already, you will be landing in this page. And you can see here Route 53 does not, okay, it is still refreshing. I'm trying to show the regions option. Route 53, like a CloudTrail or a CloudWatch, is region in specific. It just applies to all the regions. So you don't have to choose a region for Route 53. And you see the four different options, that is DNS Management, Traffic Management, Availability Monitoring, and Domain Name Registration. So this is what I said. This is one of the costliest services Amazon provides in Route 53. You can shape the traffic, reroute the traffic as the image here says. It is very helpful if you have a very complicated application and you want to see how the traffic and routing policies should look like. It is a very visual tool, very jazzy and very nice. Of course, it comes with the premium attached with it. So we will start with DNS management now. We are going to get started now. We are going to set up a private hosted zone now. I'm going to set up two EC2 instances and try to connect to each one from another one using the private domain name that I'm going to use. So I'm going to click on create hosted zone. It just try to refreshes and it says that I don't have anything as of now. Let me go ahead and click on it again. So it opens up a tab on the site. I think you can see that. I'm just going to say my private zone demo.com and just going to say demo zones. This comment is absolutely user friendly. You can type whatever you want, and here is your public or private hosted zone that you want. I'm going to create a private one, so I'm going to change the type from public to private hosted zone, and it is going to ask me which VPC I want to create and which region. And if you remember, quite often I used a demo VPC. Interesting, I don't see the other one. Okay, Mumbai is anyway still available. If you can see it, I am going to choose the Mumbai demo VPC, because if you remember, the private hosted zones lives within my VPC. So I need to choose the VPC and within a particular region. I'm going to select that, and it also gives me a friendly hint, says please enable these two options in the VPC. I'm going to click on VPC here. Let me close this as well. I'm going to click on VPC and open it in another tab, and let us go ahead and create it. Just click on create. That's it, we are done. It is spinning on my screen. You will be seeing it in a short while. Okay, great. So we have created our first private hosted zone or hosted zone, let us say, and by default you have these two records for any hosted zone. These are my name servers. DNS servers, and this is my statement of authority server record. So anybody querying for me and the answer comes from these servers will say that this is an authoritative answer. That is how SOA records are. By default, you will get these two. And for creating a record set, we will go ahead and click on this one, this big blue button. Before that, we need instances for which our endpoints or targets for which we need to create record sets, like where the traffic has to be sent. So for that, I'm going to go and start my EC2 instances. Before that, as Amazon said, let me go ahead and verify whether enable host names and all those things are enabled. For that, I'm going to my VPC. I'm selecting my demo VPC and I'm going to actions, and here you see the two options, edit DNS resolution, and it is selected as yes, very good. And I'm going to choose the other option, which is going to say edit DNS host names, and that is also yes. So we are good at the VPC level, and I'm just going to check whether my security group is allowing port 80 traffic from the external world. In case we set up a website, static website, we'll just check it out from world traffic. So if you see, I have set up SSH as well as port traffic from the external world. So let us go ahead and start our instances. I'm going to launch two instances. As usual, I'm going to start from my Red Hat. And leave it as the defaults. Here I'm going to select my demo VPC. Let us go through this quickly. We have seen this many times. I'm going to put one in the public subnet, and for one of them only I'm going to enable a public IP address and not giving any roles here. I want to set up a web server so I can bring some traffic here. I've just written the quick code. I'm just going to copy it now. So we have typed in this our small web server. We have set up our web server. Let us go ahead and review and launch it. Oh, security groups, missed it. So this must be in 1A subnet. Let us go ahead and create one more server in the 1B. I'm just going to remove it. Let us duplicate this page. Oh, interestingly, I had something running. Okay, let it be like that. Let me just rename this server as home private hosted zone demo web instance. Okay, that should be clear. Okay, we have it running. I'm just going to check this to see everything is all set up here on that server. It's taking a while. Okay, meanwhile, I'm just going to set up another server on 1B, and I'm not going to give any private IP addresses. And we are going to try and register that server in the DNS records and try to reach that server using the domain name now internally. Next, okay, demo VPC, subnet is B. I'm not going to use this option. There is no public internet access for this server. It is going to stay like that. I'm not going to set up a web server also here. Let us leave it as it is. No volumes. Private hosted zone demo private instance 01. Something to know what that instance is going to be. That is what tags are always. So always give a tag. and yesterday also in the summit they reiterated the importance of tags. Okay, I'm going to launch this one. Meanwhile, I'm just going to refresh this and to see if all is good. Okay, so one server is set up with a public domain name. So let us wait for this instance also to pop up anytime here. We are going to create record sets one by one. Okay, so first I'm going to create a record set for this server, and I'm going to use the private IP address of this server now. You can use anything, it doesn't matter. So where is my DNS? Let me close Route 53. I mean VPC, we don't need that. So we are back on the Route 53 console. We have two servers. One is having a web server running, another one is a private with its private IP address. We are going to create two record sets. I'm going to create the first one now. Let us call it, what was the name of it, guys? Give me a name quickly, or easy to remember name, or should we tag it more easy to remember some names? Give me some names, easy to remember. PRIV01. I'm going to use the same host names for there when I'm registering. PRV02. 02. What is happening? 02. Okay, great. So this is how I'm going to register here. That's our PRIV01, and my server name will be called prv01.privatehostedzonedemo.com. Through that address internally, I should be able to reach that server. I'm going to create a record. Remember the different types of records we talked about. All of them are in the drop-down options. I am going to point to an Apex record. So I'm just pointing it to a record and say this is my IP address. So if I copied it, let me see if it is there. Okay, just to go ahead and verify. My priv01, that is private zone 01, is 10.81.1.38. I'm just copying it the same thing here, and I'm saying simple routing policy, and I'm going to click on create. And I'm not creating any alias for now. That's what you need to remember now. Okay, so my private host and zone is available. Let me connect to that instance. I should have done that before. What is my public IP address so that I can connect to the server? Let me rename the session first to priv01, putting the public. Oh, I didn't copy it. 35, it should end with 152. Okay, great. I'm just going to check my key, whether I'm using the Mumbai admin key. Okay, let us connect to it. I'm just going to go to root to avoid any admin issues. I'm just going to ping my public name and it should give a response. Firewall issues, yeah. Now you remember I did not enable ICMP. So if I SSH to the other instance with the IP address of the second server, it will work. But what I'm going to demonstrate is using the host name of the second server now. So let us go ahead and create a record set for the second server. I'm going to copy this IP address. I'm going to create another record set, PRIV02. I'm going to click on create now. So we are in 81.1.38, that is my PRV17. Let me try this. It didn't work. Okay, I need to change it in the host names. I don't want to do that anyway. SSH PRIV2. Let me copy the host name. That is better. I'm just going to copy this and put it in my console to try to connect to the server now. Okay, my copying activity is sloppy. Strange, isn't it, guys? I'm not able to copy a single text properly. Okay. So you see, voila, I'm able to connect to my instance using a DNS host name that is a private host name that I used. I can give yes here, but it will reject because my key will not be accepted. I'm just going to give me a one moment. I'm just going to pause the session, record session. I'm just going to. So that is all that is there to be shown in private hosted zones. Create a hosted zone, create record sets. Like I shown here, you can have any number of record sets, and that any number has a ceiling of 10,000 as of now. Probably if you need more, you contact Amazon and they might be able to help you with limit increase. So that is all we do with the private hosted zone. Coming to public hosted zones, let me show you how to do that now. Before that, so this is our web server delivering the website, a single line website, and we are creating a record set for our navnirman.net hosted zone, and I'm just going to put in the IP address here to complete the record set. You leave www empty so that the apex record points to this IP address, and we'll create another record set. So you see there is an apex record created here for a record, and then what we are going to do is we are going to create another record set for www, and we are going to say this is a CNAME and which should indirectly point it to my A record only. So it gives me an example of what should go in this value field. I'm going to say it goes to my navnirman.net. So somebody tries to come to www, it will again redirect them to this IP, this host name, and this host name will in turn redirect to my IP address. So everything works smoothly. It usually takes some time, a while. I have not exactly measured it, how long it gets to propagate, but that should not stop us from testing it out. If it is an error message, we can try out and come after some time. Awesome, right? You can also go ahead and try it. You can see already my domain name is propagated, and if I type navnirman.net, it is pointing to my website. And if you can see, sometime back I opened the page and it is not showing that it cannot be displayed. Let me try the www hostname, www.navnirman.net, and to type that, let us see if the routing and redirecting and CNAME and all those things are working. Awesome, it is working, right? So this is how you set up a domain name and you point it to a particular server. In case what you, let us say you're having a static website and you want to point it to a static website, what you need to do is you need to create a bucket which is similar to your domain name. So if I want to create a website for a static website for navnirman.net, what I need to do is I need to go to s3.aws. I don't remember the name. Okay, let me do the default way. Oh, great. So far I've shown two demos. One is private hosted zone, and next one is a public hosted zone. And in public hosted zone, we used an EC2 instance as your data source or your website hosting service. Now I'm going to use S3 for my website hosting service. This is the second demo part. So as I said, I will repeat again, for S3 to be used as a static website, the bucket name should reflect or mirror the domain name. You need to create two buckets. One is with the www, one is without the www. I was experimenting last week, and if I am lucky, that data should already be here. If not, we can quickly set up a website. Okay, great. I have not deleted it. You can see I have set up two buckets. One is nownermon.net, another one is www.nownermon.net. So if I open the first one, I'm just going to click on that, and I'm going to click on properties. I'm just showing you static website is set up here, nothing else. We have seen this all before. I'm just refreshing those things. I'm clicking on static website hosting, and you can see the URL is mentioned as nownerman.net.s3website.ap-south. I'm just pointing it to my index.url, error.url. I'm going to copy and paste this in the browser to see what is the website we should be seeing when we point our domain name to this one. So we should be seeing something like this when our domain name points to this S3 bucket. I'm just going to put this in the chat window, so anybody wants to pull this website and see what we should be getting, this is the information. Okay, so what I'm going to do now is I'm going to go to Route 53, and I'm just going to delete these two records because it is pointing into an EC2 server. We don't want that to happen. We want to point it to an S3 bucket for now. So I'm going to delete these two record sets, delete it. So if you want to be sure, you go ahead and refresh this page. It should more or less should not work. Because of caching, it will work for some time, but within a short while, it should stop working. I don't know how much is the DNS refresh policies with AWS, but within a short while, it will stop working. So I'm going to create a record set for nownermon.net, and here's where the alias part comes in. So you see, if I click on alias part, it will point to my website in S3 bucket. So already my S3 endpoints are already picked up, and it shows here as you can see. I'm going to choose this option, and automatically it creates an alias for that, and let us leave these two for now as it is. Click on create. And I forgot to show you what is in that www bucket. Let me just go back to my S3 bucket, and I'm going to show you what I have put in my bucket with the prefix of www. I'm just going to go to this bucket, and just to be sure, see, this is my bucket name here, Amazon S3, this is my bucket name, and you see my bucket is empty actually speaking. But if I go to properties, and if I go to static website hosting, I'm waiting for it to refresh. You see here what I have done is I have redirected all my requests to a target bucket, which is my root domain, nownermon.net, without the www prefix. So that is how I will redirect all my traffic that is coming to this URL to my other bucket. So I always have only one bucket where all the data will go in, and all the versioning and tagging and everything takes place. And this bucket is just a placeholder so that anybody trying to access my website using this prefix will be redirected to that URL. So what we will do is we will create another record set for www prefix also. I'm just going to type the www, and I can either point it to my CNAME, or I can either create a CNAME which will point it to my, in other words, I can do it at Route 53 level, or I can do it at S3 level. Let us do it at S3 level. So put a prefix, create an A record, and create a pointer to my S3 bucket. And the S3 bucket will in turn point it to my A record here. So click on create. So anybody has already tested it? Is it working? I'm just going to open another browser window. I'm going to type nownermon.net, and we should see a big black color ugly window now when it is working. So you see, I have the previous window also open here. If I click on that, you see we should be getting a single page website if we are pointing it to EC2. Now we pointed it to S3, we are getting a different website. and the www part also should work now. Yeah, it is pointing to my now Nirman when I type www prefix also, and it is redirecting to my website now. So you can do the same thing with CloudFront also. I'm going to my Route 53 website, create the record set, and for aliases, if I click on edit, just one second, let us do this. If I click on that, if I have set up a CloudFront caching mechanism for my domain name, then that endpoint will also be visible here, and I can use that also. So this is all is there for setting the routing record sets. So remember the routing policies I talked about. Here is where the routing policies are coming over: simple, weighted, latency based, failover, and geolocation. Let me just change this. Let me leave it as S3, and let me just go to geolocation. When I choose geolocation, it gives me an option of which location I want to choose, which country I want to choose, all those. Let us say I want India. I'm going to choose India, and it is asking me an ID to my data center. It is a description of this record. That's it. It's nothing specific. It is nothing unique. Nothing. It is unique. It is nothing configuration setting, I should say. So route for India users. So I'm just going to click the record set for that. So you can see a slight change will be there for the alias. That's it. You will not feel this anywhere, and you will see that geolocation is set in here. So these are all policies for shaping the traffic that is coming to your domain name. So you can have a particular record set, particular server in America, and point it, have an A record, and say, one second guys, let me just close out the doors and the noise. I hope that is better. That is the best I can do as of now. What I was trying to say is you can have another server in America region which is data replicated, and send all your North American users to that server using a geolocation based routing policy. Likewise, you can have multiple routing policies. One by one you can check it out. There is nothing complicated here. Here latency, that is which region you want to send. For example, I am in Asia Pacific, that is Mumbai region, so I'm just going to choose AP South, and I'm going to say again use record for Mumbai users, or record for Asia Pacific AP South users. So that is how you change your policies, different policies for your posted zones. It should reflect here. I change it from geolocation to region specific. So any user coming from this region will be pointed to this record. You can have multiple records. You can do different routing policies you want. So that is all I wanted to show for today. Is there anything you want to ask right now? Anything that is not clear for whatever happened today?